Hi class, today's lesson is 12-2. It's on experimental probability. Our purpose is to find the experimental probability of an event. There are 5 vocabulary terms, so I want you to go ahead and turn to the back of your composition books and write these terms down. The one saving grace is that their definitions aren't very long at all. First term is experiment. An experiment is an activity involving chance that can have different results. If I flip a coin or if I roll a set of dice, these activities can have different outcomes, different results. I flip a coin, it gets head or tails. If I roll dice, it can get a number of different number combinations. Outcomes. Outcomes are the different results that can occur from an experiment. As I've said, flipping a coin, get heads and tails. If you flip one die, you can get either 1, 2, 3, 4, 5, or 6. An event. An event is an outcome or a set of outcomes. If I flip this coin twice, I might get heads and tails, or I might get tails and heads, or I might get heads and heads. That's an example of an outcome or a set of outcomes which we know as an event. Trial. A trial is each repetition of an experiment. The number of times I flip a coin, the number of times I roll a set of dice. Experimental probability. Experimental probability I want you to write down in 2 different ways. One is a definition, and then the other one is a mathematical equation. Let's look at it. Experimental probability is a ratio. What is it? Well, it's the ratio of times the event occurs to the total number of trials. Here's expressed mathematically. Here, experimental probability is the number of times the event occurs over the total number of trials. We'll see that in our next example, or actually in one of our next examples. Pretty simple activity here. It says, for each experiment, identify the outcome shown. Here we have the tossing of 2 coins. How do we write the outcome? We write the outcome within parentheses. This one is heads and tails. That's an outcome of that particular experiment. Next, we have 2 dice that are rolled for us. What's the outcome here? The outcome here is rolling a 3 on one die and a 5 on the other. Let's go to example 2, and this is where we determine experimental probability. It's always based upon something that's done. Here, for 1 month, Tasha recorded the time in which her school bus arrived. She organized the results in a frequency table. So here's the time breakdowns. Between 7 and 7:04, her bus arrived 8 times. Between the times of 7:05 and 7:09, her bus arrived 9 times. And between 7:10 and 7:14, her bus arrived 3 times. It says, find the experimental probability that the bus will arrive between 7 and 7:04. So we're going to take a look at this right here. And we see that the probability of the bus arriving between, and I'm going to write down some abbreviations here, between 7 o'clock and 7:04 equals, well, the number of times that outcome occurred, and that occurred 8 times during the time that she was running this experiment, out of how many total trials, how many total times did she observe this bus arrive? Well, there's 8 plus 9 is 17, plus 3 is 20. So she watched this bus arrive, or recorded it arriving 20 times. So 8 out of 20 times it arrived between 7 and 7:04. And we can simplify that ratio down by dividing both the top and bottom by 4 to 2 out of 5, 2 to 5. Next problem. We have Asks us to find the experimental probability that the bus will arrive before 7:10. So I'm going to write down P, the probability of the bus arriving before. Again, I'm going to abbreviate here, before 7:10. I'm going to end that parentheses, put my equal sign there. In this case, before 7:10 would include this number as well as this number. So 8 plus 9 is 17 out of a total number of trials, which we determined earlier was 20. So 17 out of 20 times the bus will arrive before 7:10. The last example, I better go ahead and erase what I put up there, although you can pause and take a look at that as well. But here, Ian tossed a coin 30 times and recorded whether it landed on its base or on its side. Based on Ian's experiment, which way is the cone more likely to land? Well, it landed flat on its base, a circular base, 7 times. It landed on its side 5, 10, 15, 20, 23 times. So the question is, how do these compare? So let's figure out the probability for the base. Probability for the base is equivalent to, well, there's 7 times out of a total of, and if we combine these tick marks, they would equal 30. So 7 out of 30 times it landed on its base. Not a lot of times. And the probability of landing on its side is 23 times, 23 out of 30. Going back to the question, it says, based on Ian's experiment, which way is the cone more likely to land? Well, based on this, it's going to land more than likely on its side. So I'm going to write down side, circle it. That's our last example, and now it's your turn. Your turn to go ahead and complete the problem. Here it says explain, and that's important. You're explaining. It's not just an answer. You're explaining what you're thinking. Explain whether you and a friend will get the same experimental probability for an event if you perform the same experiment. Suppose you perform a flip of a coin, or 20 flips of a coin, or 400 flips of a coin. Would you get the same result as your friend who would do this exact same experiment? Number 2 is tell why it's important to repeat an experiment many times. Why don't we just stop at 2 flips of a coin? Why is 10 flips better? Why is 20 flips even better? Why is 100 flips better than all those? All right, we'll see you in class.